Okay, so let's take a look at problems like this where the sequence alternates, positive, negative, and for this, the ratio we are multiplying by is -2 each time. That's how we can have this alternating pattern, and that produces some problems here down the line. So if your question is which value is going to, which term in the sequence is going to have the value of 1280, say, value of 1280, and we didn't want to just make a table out to that point. There is a more sophisticated way to do that, but we'll run into some troubles with some of our definitions. Now this pattern here, the equation starts at 5 and multiplies by -2, and now there's a reason for having the parentheses, in that if you don't include them, this minus sign can make a mistake in some of your calculations. So at this point, we're going to substitute in 1280 into UN and solve for what position that number takes in the sequence. 1280 equals 5 and minus 1. And again, don't distribute, divide by 5. Let's go ahead and do that real quick. 256 -2 and minus 1. Keep it in the parentheses because if you don't, your calculator might think the 2 has the exponent, but not the negative in front of it. So noticing here, the second number is negative, the fourth number is negative. Every number thereafter that is even will have a negative value. And so we have to keep that in mind as we're moving forward. So this is a positive value, so we should be getting a odd number as an answer. Now, when you go to do this, the natural solving procedure is to do a logarithm, and -2 would have to be the base to cancel out with the -2 in the problem. And we'll do it to both sides because it's algebra. And that is where we run into our problems, because if we go to plug this in, we'll get a complaint from our calculator. And so let's go ahead and try that here. If we go ahead and log base -2 and 256, we get what is a non-real answer. Now that is false. At this point, you should be developing a healthy skepticism of your calculator's abilities, because it is in fact possible. The problem comes with the limitation of logarithms. The definition of logarithms is being broken here. There is no such logarithm that accomplishes this calculation. And here's what I mean by that. Let me take a different problem, like -2 to some power equals 4. And you should be able to see, well, that'd be -2 squared. -2 squared, negative times a negative, will actually produce 4. And so it's possible. Now, if we instead try to solve this with a logarithm, there's a base, there's the exponent, and the 4 is the answer, so to speak. The same information, but presented with the inverse, that is the logarithm. -2 of 4 equals the exponent x. By definition, logarithm must have a positive base. And so if we go to calculate this, even though we can see the answer is 2, x equals 2, but we know that from just knowing our numbers. If you go to calculate it, you'll get a non-real answer. And so anytime you have a negative as a base here, you have to do a little bit different process. And what we're going to do if we want to solve this, so calculator says non-real answer. Let's just confirm that. You have 2, and if you change this to a 4. Is that going to do anything? And no, calculator still doesn't like that process. And this is why that -2 in the base, which is that position right there, is a mathematical no-no. So here's how we're going to work this out. We're going to pretend, since we do know that it has to be an odd number, it's going to be 1, 3, 5. One of those odd numbers is going to be positive, and we'll determine its value. So we're going to pretend, for the sake of calculating, we're going to pretend that this is a +2, since it won't make a difference in the case of the positive values. So pretend, if I can spell this right, pretend that actually the problem that we're solving is this one. And the answer will be no different, but we can carry on with our solving procedures like before. So we're going to log both sides. And now we want the 2 to go away, so the subscript on the logarithm has to be a 2. It cancels there. And n-1. And now we are able to move forward with the solving. So at this point here, let's go ahead and find that out. The 2 here, 256. And that would be 8. All right, so 8 equals n-1, which means n is 9. Now, just to show that that didn't make a difference for us to pretend that it was positive in the first place, let's go ahead and plug it back in. We're going to test n equals 9 back in our original formula. If we plug this in, it should produce a positive 1,280. So un equals 5 times -2 to the n-1. I'll just go ahead and put that as 8 here. So n-1 to the 8th power gives us, I did, again, this is why the parenthesis matters. So the calculator is thinking that the 2 has the 8, but the negative in front does not. So let's go ahead and do this very carefully. Parentheses, -2 to the 8th does in fact make a positive 1280. So it's okay in this case to pretend. We just have to be a little savvy about how we're going about solving this problem.